Welcome to another video explaining the universe using the particle model. Today's video asks the question, why are all the planets on the same orbital plane? Normally I wouldn't have asked that question, but I happened on a video that was titled, that's its title, Why Are All the Planets on the Same Orbital Plane? This was released by YouTube this year, March 20th of this year. And very early in the video, you see a drawing, not a video or a photograph, but it's a drawing of the sun and the planets orbiting, and they're all in the same plane. Well, you can watch the video, and it's a little bit frustrating to watch it because he never answers the specific question. He goes into a lot of detail about how things formed in the beginning and drawings and words, implying that eventually these things, because of all these reasons, end up in the same plane. But he never answers the question. He talks about things like clumping. In the early development of the universe, things clump together. And yeah, we get it, that happens. But technically, what is clumping? The answer, the specifics of how that clumping happens is not stated. And he goes on further. He says some of the particles are sucked in. Oh man, wow. They're sucked in. Must have had vacuum cleaners in the early universe to suck in the particles. What kind of technical explanation is that? And then he goes on to talk about how orderly systems come from chaos. And of course, early development, it looks like chaos. Somehow we have orderly systems. How does it happen? Apparently, clumping and sucking is the answer. And he makes the statement, self-organizing emergent structures. Structures, presumably our solar system is one of these structures that are self-organizing. Very intelligent structures. They know how to self-organize. Well, order can come. Order can come from chaos in our universe for two reasons, but this would be in a mature universe, not in a forming universe, at least the way he describes it. It appears, for whatever reason, these structures are made, eventually end up in clump, to use his word, together in spheres. Spherical seems like the shape in the universe. And if you have gravity around and you have a spherical sun, then you can have self-organizing emergent structures that are orderly. Spherical objects, primarily, not exactly, and gravity will give you an orderly system out of chaos. In fact, that's how G1 gravity works in the particle model. I mentioned these because this happens over and over again. Modern science tends to tell us what happens, but not what makes it happen. So he tells you all this clumping and sucking and orderly systems out of chaos, self-organizing emergent systems, and you're supposed to know now why the planets are all in the same orbital plane. Well, part of the video is kind of interesting. It's a cute little demonstration, and I'm going to play that video for you now, and it answers the question Not why they're in the same plane. In fact, with this video, they're in different planes. But it's kind of a fun video, and so I will play that for you.
Which is just like what gravity does in three-dimensional space in the universe. Dan throws balls in both directions around the central object, and the balls orbit until they collide with another ball going the opposite direction, cancelling their momentum out. And what you are left with are just the balls that didn't collide and are all going in the same direction. Now, friction from the Lycra wouldn't happen in space, so you can imagine particles continuing to orbit, unlike the balls that slow down eventually on the Lycra. Also, this is kind of a two-dimensional representation of what happens on a three-dimensional.
Well, so you can see how when something enters our solar system in the wrong direction, it may survive for a while, but eventually it's going to collide with something, and it's not, we don't want to have a collide with the Earth and have the Earth go spinning off in some odd direction. But yeah, you can see mechanically how over time these systems develop such that all of these objects, all of the planets, orbit in the same direction. Well, there's a phrase that words that we don't often use: retrograde and prograde motion. Retrograde motion in astronomy is in general orbital or rotational, and I use the word spin in place of rotation. The orbiting motion, the spin motion of an object in the direction opposite the rotation of its primary, that is the sun. Retrograde motion opposite to the rotation of the motion. That's retrograde. You see here, though, in the solar system, the orbits about the sun of all planets and most other objects except comets and stuff that come through, they're all prograde. That is, they orbit the same way the sun is spinning, or whatever the central body is. They orbit the same way. Now, the second thing that's interesting is the North Pole, if you will. Except for Venus and Uranus, planetary rotations, spins, are also prograde. That is, as if the sun is spinning counterclockwise, so is the Earth spinning counterclockwise, which means the North Pole of the sun and the North Pole of the Earth are pointing in, not exactly, because there's tilts and so on. There's, what's the word, precession of the Earth. But Venus and Uranus, they spin clockwise as they go prograde around the sun. They spin the other way, and therefore their North Pole points to the south. Kind of interesting how those two are highlighted here. Well, again, finally, are they on the same plane? I had to go get this drawing from Quora. This is a looking from the edge of the solar system. It doesn't say exactly. You assume from the plane of the sun, but it's got all 9 planets. And clearly, Pluto is drawn here, is way off in terms of being in the same plane. And you can see here, well, maybe Uranus is. Oh, look at here. See the arrows on Neptune? There's the North Pole. Saturn, North Pole. Uranus, that's really strange. I don't know if this is drawn right at all, but it is pointing down somewhat, and so you could say that it's pointing down. And Venus, North Pole, is pointing down. And you can see here that the orbital plane of the 4 inner planets are not all in the same plane. And there's the North Pole of the sun and the North Pole of Venus clearly pointing down. Now, they're not all in the same plane, but people seem to think they are, and many other drawings that you see tend to show them that way. Well, to get a clearer picture, uh, I found this drawing also from Quora, and it uses the ecliptic plane as a reference point. Now, the ecliptic plane is the name for the orbital plane of the Earth. So you have the center of gravity of the center of the sun, center of the Earth, and that's its orbital plane, and it's set at 0 for reference. So the ecliptic plane becomes the reference. But as you can see, the rest of them are not there. They're not in the same plane, and you can actually look this up and get the degrees, but this one is almost 10 degrees off. That's Mercury. That's the end of Mercury, Venus, Earth, Mars, Jupiter, Saturn. This one's about 5 degrees off, and this one's 5 degrees the other way. They're clearly not in the plane, same plane. So the question is, why do people keep asking? A lot of people ask, why are they in the same plane? And how did they get there? This is my answer. I actually did this many years ago and had a video on a gravity group that I was hosting. Well, the sun spins and is elastic and therefore has an equator. All objects in the particle model are elastic. There is, as long as they're made up of atoms and subatomic atoms, and if they exist, subatomic atoms all the way down, that makes them elastic. They're space, and they move. And if they're spinning, you're going to get an equator. The Earth has an equator, and the sun has an equator. Now, this is the equatorial plane of the sun. So what I'm saying is there's a bulge here and there's a bulge here, which gives it a little bit extra mass in this direction. And here's the sun. By the way, it's about 11 degrees off of the sun's equatorial plane, but this is still the ecliptic from here to here. This is the net force of gravity in terms of the particle model. The net force caused by G1 particles is F1 on the Earth here, F1 on the Earth here. You can take this force, as it's generally pointing to the center of the sun, and break it into two pieces. A vertical piece pushing down here, and a horizontal piece pushing to the left. There's a small force here pushing down on the Earth. So the opposite is true. When the Earth gets all the way around here in its orbit, there's a force pushing up and one pushing over towards the sun. I contend that that force is tending to bring the Earth towards the sun's equatorial plane. So the answer as to why there appear to be, or you would understand that they could be all in the same plane. Of course, the difficulty here with this force, and I know that's a tiny arrow, is that the closer you get, the Earth gets to the sun's equatorial plane, the smaller that force is. And it's like you're never going to get there. It's going to take a long time. Now, you take one of the ones like that are 10 degrees off from here, they're going to have a stronger force and they're going to move quicker, at least initially, but then they get less and less and less. It's going to take a long time. So everything, all particles and atoms and larger objects are elastic and have spin. That's my opinion. Okay, our moon does not spin, but this is due to tidal lock. Watch my video titled, Does the Moon Spin? I'll list this in the description so you can find it. Interesting, the moon does not spin, but if it weren't tidal locked with the Earth, it would certainly spins. So that's the answer. Not only am I answering it, but I would be predicting that they would get there someday. Oh, excuse me. My name is Bob Hilster, and I am your particle model guru. Tune in next time when I'll explain more of the universe using the particle model. Thank you for your attention.